Hello. Now to recap the previous lecture. So basically, if a body had absorbed some Q amount of heat, okay, some absorbed QA amount of heat, so later on it will emit also some QA amount of heat. So as per Kirchhoff's law, okay, the ratio was constant. The ratio of emission upon absorption turns out to be a constant. Now let's suppose that a body is a good emitter, like it can emit very large amount of heat. So how is that possible? That if the body is emitting energy, it means that it had to have energy at the first place. And how would that body will have that energy? That is by absorbing energy. Okay, so the point that I'm trying to make is that a good emitter is also a good absorber of heat. Okay, it's a very crucial point that if a body is absorbing some amount of heat, okay, then after absorbing will be the condition that it will emit that heat. Okay, so to emit the heat in the first place, we need to have energy. And where will that energy come from? The energy will come from the body which in some previous case absorbed some amount of heat. So basically a good emitter is a good absorber of heat also. Now this brings me to the point of a black body. Black body, okay, so black body is basically a theoretical substance in which any amount of heat which is given to this black body, this body absorbs every amount of that heat. Its shape is roughly like this. It's basically a two-walled surface with the inner wall being a good reflecting surface. Okay, and the outer one is basically thermally insulating, so that the energy from inside does not go outside. It basically shields the surroundings out. So there is a very tiny opening. What happens that if infrared ray or basically a heat energy enters, so what will it do? That this is a perfectly reflecting surface and infrared ray are the ray which carries heat. So these rays enter this black body, and after various reflection, the chances of this infrared ray or this EM wave to get out of this hole is very less. So what happens that once a ray enters, it goes successive amount of reflections, and that ray is theoretically actually it stays technically inside this body. So basically what did we do? That is, we theoretically, okay, created a substance which can absorb any amount of energy. Again, this is a theoretical substance, okay, that we are assuming various things, that if an EM wave, if an infrared ray, okay, enters this body, it goes successive amount of reflections, and due to this successive amount of reflection, it basically stays inside forever. Okay, so this is my theoretical assumption. Practically what happens is that we are giving this body some energy, And what this so basically like this infrared ray of light, it carry 10 joules of energy, and this 10 joules of energy is now inside this black body. Now this black body will have a tendency to emit that radiation as per my Perforce law. Okay, that due to it has the excess energy, it will try to emit that energy. And how will it do that? By emitting infrared ray of light out of this body. So that infrared ray of light won't come out from there, but it will come out from this hole itself. So what practically happens is that we give it some energy, okay, and some energy comes back. And by designing carefully designing and all, we can limit the energy which is coming out. So basically the energy going in is more. Okay, this we design it so like practically, but for theoretical considerations and derivations, and for our further numericals also, what we will consider that if we give some energy to a black body, it goes on successive reflections and basically stays inside or trapped inside forever. And one more assumption is that if so we are supplying this with energy and we stop giving it energy, okay, and this hole is remained open, so what will happen that this black body will emit those energy back. The energy that we gave the black body at the first place, all of them will come out. Okay, so in the first case, black body was a perfect absorber. It absorbed, and after we stopped giving this black body any amount of any energy or anything, infrared ray, anything, we stopped giving this black body that. So after that we can see that the energy that was stored inside the black body will come out. So it becomes an emitter at that case. But black body's definition is that it's a theoretical substance in which can store any amount of heat energy given to it. Okay, now okay, this is not visible. Black body is a theoretical substance. Black body is a theoretical substance which can absorb any amount of energy given to it. Now when we are giving it energy, it will simply store. When we stopped giving black body heat, okay, when we stopped giving the black body heat, the energy that it absorbed in the first place comes out. Okay, so we will be studying both of these when we are giving black body and it is absorbing everything, and the second case in which the black body is emitting those energy. Okay, we will be studying those separately. Okay, now after this we need to define certain things. So first things that comes is absorptivity. I'm not sure about the spelling though. It should be B. Absorptivity of a substance. So absorptivity was basically what in last lecture you can see A was equal to radiation or the heat absorbed heat absorbed by a body upon the total heat that was given to the body. Okay, heat absorbed by body upon total heat given to the body. This I have discussed in the last lecture. So in this case, in the case of black body, we will be modifying this a bit. Okay, now absorptivity of a substance A will be written as radiation power absorbed by a body upon total radiation power given to a body, where we can write first point here that radiation power is basically equal to the heat absorbed, or in this case given to the body upon time. Okay, this is radiation power. Now in second step I'll be modifying this thing. Total radiation power, this can also be equal to the total radiation power absorbed by a black body, because we know that if we give any amount of energy to a black body, it will absorb it. Okay, so absorptivity of a substance is basically equal to the radiation power absorbed by that substance upon the total radiation power given to that body. Now if we compare this body with a black hole, we know that if we supply some energy to a black hole, it will absorb that amount of energy. So we can rewrite this equation. Absorptivity of a substance is equal to what? Radiation power absorbed by a body upon radiation power, okay, absorbed by a black body. So we are comparing absorptivity of a given body with respect to a black body. Okay, now same will be defining emissivity of a substance will be equal to radiation power emitted by a body upon radiation power emitted by a black body. Okay, so what we learned here is that basically a good absorber can be a good emitter of heat. Later on we saw black body is basically a theoretical substance in which we can give any amount of energy to it and it will store that, and this is a theoretical assumption. Practically it is not possible, but theoretically we give it any amount of heat or any amount of energy, it will store it, and as we stop giving this energy, what happens that this black body stored some amount of energy initially, it will gradually lose that much amount of energy, so it becomes an emitter also when we stop giving energy. Okay, So later on, moving on, we actually defined some terms: absorptivity of a substance and emissivity of a substance. Absorptivity of a substance is basically equal to the heat given to a body upon heat given. Absorptivity of a substance is basically the heat absorbed by a body upon total heat given to it, and we have modified this equation a little bit in terms of power. Okay, so radiation power is basically equal to heat upon time. So this becomes radiation power absorbed by a body, okay, upon total radiation power which is given to it. Okay, and we know that now what we are doing here is that we need to compare absorptivity or emissivity of a body with respect to a black body. Black body is my standard here. Okay, with reference to black body, we will be comparing any absorptivity or emissivity of a given body. So we know that in this case, in the denominator, radiation power given to a body will be equal to the radiation power absorbed by a black body, because black body absorbs everything. So the equation becomes my radiation power absorbed by a body upon radiation power of a absorbed by a black body. Same in similar terms, when we define emissivity, the numerator just becomes radiation power emitted by a body upon radiation power emitted by a black body. So radiation power emitted by a black body becomes the total heat that was absorbed in the first place, or the total heat that is given off. Total heat, okay, Q. So I'll be talking about Stephen's law in the next lecture, which is basically continuation of this topic, radiation. Okay.